Hello and welcome to ILSI Europe webinar series. My name is Matthew Flourakis. I'm a scientific project manager at ILSI Europe and responsible for the Dietary Carbohydrates Task Force, who is coordinating this activity and this specific webinar. So today's webinar will be on dietary glycemic exposures for sustained dietary intervention in population without diabetes. And it's a great pleasure for me to have Edith Peskens, who will be giving the presentation of the latest results of the Dietary Carbohydrate Task Force. But to start with, I will give you a brief introduction of ILSI Europe. And ILSI Europe delivers science-based solutions that improve public health and safeguards the environment. And to do that, we use four main pillars. We foster collaboration between different stakeholders, and this includes obviously the private sector with the industry members, but also the academics and public institution. We identify together in this collaborative mode, we identify common challenges that really helps improve public health and safeguard the environment. These common challenges are solved by providing high quality science. And once the science is actually published, we communicate and disseminate wisely all the results of the activities we are leading within ILSI Europe. And the Dietary Carbohydrate Task Force is really a great example of this mode of working within ILSI Europe. In terms of collaboration, the Dietary Carbohydrate Task Force is composed of 6 industry members, and you have the representation of those members in this slide. And the chair of this task force is Dr. Sophie Vinois, and she had this very nice quote to say about the task force. Basically, we target scientific excellence, addressing the scientific challenge about carbohydrates. And through the dynamic expert groups and task force meetings discussion, we state about the most recent published research to guide, inform, and influence all our stakeholders. So beside the industry members, as I mentioned, we have 2 scientific advisors, and we have Professor Ellen Black, who's professor in human biology at Maastricht University. And we also have, and sorry for the typo, we also have Professor Annette Boyken here, who is professor in public health nutrition at the University of Paderborn in Germany. In terms of challenging we are addressing with the task force, we are really exploring the link between carbohydrates and health. And the aim and the objective of the task force is to understand the link, again, between carbohydrates and health, and particularly the relevance of controlling glycemia. We want to identify the types and the quantities of carbohydrates that should be consumed to optimize human health. In terms of publication and science, the Dietary Carbohydrate Task Force publications are widely recognized and cited throughout the scientific community. For instance, we have, since the creation of the task force, we published 8 open access peer-reviewed publications, and this publication on average are cited around 156 times. In 2020, we already published 3 papers, and one of the latest papers we'll actually be presenting during this webinar today. We also have, we published outside of this peer-reviewed publication, we published educational material, and that's what we call the concise monograph. So it's really a publication that is geared towards more wider audience, and this is what we call the concise monographs. And the task force published already 3 of those material. And in terms of communication, the output of the task force is widely disseminated and communicated to external stakeholders. And for instance, in 2019, our publications and our speakers were disseminating the activities of the task force, for instance, at the FENS in 2019, where we estimate that we reach around 120 people participating in the audience. And we, in 2020, we also have 2 webinars planned, including this one. So, and we are also now in a phase where we're kicking a lot of new activities, and for instance, we will join forces with the Early Nutrition and Long-Term Health Task Force, again within ILSI Europe, and this is to review the relevance of carbohydrates in infant nutrition. And in parallel, we are organizing for April 2021 a webinar on the health relevance of lowering postprandial glycemia in children and adolescents through diets. So now, without further ado, it's my pleasure to introduce Edith Veskens, who is professor in global nutrition and chair of the Division of Human Health, Nutrition and Health, at Wageningen University and Research. And she will be basically introducing and presenting to you the latest paper published by the Dietary Carbohydrate Task Force.
Thank you, Matt, for introducing me. Welcome, people from Europe and maybe also from outside Europe. So I want to say good morning, but perhaps even good evening. I had the privilege of sharing a wonderful group of scientists, and we carried out a systematic review, which I want to present to you. It's clear I want to have some things to disclose. This work was supported by the ILSI Europe task force, the Dietary Carbohydrates task force, as Matt already introduced to you. And I, as most of researchers in my field, I had some funding just to disclose some major EU projects, JPI, Healthy Diet for Healthy Life on the food metabolome, and a small grant from the Dutch Knowledge Center on Sugar and Health in preparing food consumption tables for sugars. The members of the working group, like I said, are experts in the field from both academia and from the industries related to the task force. So I'd like to point out the scientist, Lorraine Brennan from Dublin, Lena Linder for the German Diabetes Center in Düsseldorf, David Mila, former Unilever, Naila Rabbani, professor in Warwick, but now also in Qatar, Wolfgang Rathmann, also from the German Diabetes Center, Koen Stehauer, specialist internal medicine, Maastricht University, and Paul Thornelli, also an expert on ages and dicarbonyl stress from the University of Warwick. So we had many telephone calls, also live meetings actually, because we started in the time that was still possible. But I'd like to introduce the topic to you first before I come to our research question. And I think it's already well known that type 2 diabetes, so diabetes in adults, is highly prevalent all over the world. So not only in Europe, we see especially high rates in the US, that's not surprising to you, but also surprise to me, for example, in Brazil and in the Middle East, and well, you can see this not here, I can show this now, in China and India, large numbers there. Can I show this? Yeah. I've now stopped sharing my webcam. I hope that this is okay with you because it's a little bit annoying for myself. If not, Matt, please let me know. So the prevalence is high. And this is disturbing, but we can do something about it because we know diabetes can be prevented. I don't want to quit. No, I want to go to the next page. Why can't I go to the next page? Sorry, guys. I think I will do it like this and not have a fancy pointer. Yeah. So what you will see is that the number, in absolute numbers, the disease is really overwhelming. And we expect to have in 2045 an increase of 51% in the number of type 2 diabetes patients all over the world. And note that only half of the people with diabetes are really diagnosed as such. In the Western world, the diagnosis is quite good. So we assume that we have about 70 to 80% of the people know with elevated glucose levels know they have it and are being treated. But in the low and middle income countries, this is much less. So we expect staggering numbers in the amount of people, for example, in Africa, in China, and in Australia. I need to go. Quit. No, I don't want to quit. Somehow I cannot shift. Yeah, now I know. To prevent diabetes, we need to start with people who don't have it yet. And we call that subjects with normal glucose tolerance. So they are, you have a glucose load, and you see an example here. And sometimes people after a standard glucose load, like in the glucose tolerance test, they have a curve like this. 30 minutes, 60 minutes, 120 minutes. That means that the glucose peak was somewhere in the beginning. So apparently there was a high efficiently insulin secretion, so which made the glucose disappear from the circulation. And then at 30 minutes, it's already gone. But usually, especially in elderly people and in obese people, we have curves looking more or less like this. Now, fasting glucose in this group is still the same, so not very different. So fasting glucose then cannot discern between these people. But with this glucose tolerance test, we challenge them and we can see a difference. So, and then we realize that these postprandial glucose levels are really very predictive of the conversion to type 2 diabetes. So this is data already from 15 years ago from the San Antonio Heart Study. They discerned 4 types of glucose responses during a standard test of 75 glucose. And you see here group number 4 with the curve looking like this, so really having higher levels still after 2 hours, are the ones with the highest conversion rate to diabetes, but also the highest risk of cardiovascular disease. These vascular complications are an important complication of type 2 diabetes, and importantly are also directly related to the glycation. So the glucose, the presence of glucose in the vascular, in the circulation. So hence, this glycemia is a very important factor. Now, if we think about diabetes, like I said, we think in theory about 90% can be prevented, and diet is the most important environmental factor in this potential prevention of diabetes. So that's why we pay attention to this a lot. You may know that there is something like called glycemic index, because we know that even when it's 50, a standard load of 50 grams of carbohydrate gives very different glucose responses. You can see that here in this example, sucrose or honey or another honey type of concentrate. The picture on glucose response on this 50 grams of load is looking completely different. So we call this glycemic index, the comparison of this curve to a standard curve made by glucose or white bread. You see here an example of some low GI foods. Low glycemic indexes are 55 or below. A high glycemic index is considered 70 or higher. So you see here, there's quite some variation in the fruits, for example, but also in the vegetables. And obviously starch foods and also snacks made of starch are the high glycemic ones. And we have shown earlier that in diabetes patients, it's really possible to reduce your HbA1c, the level of long-term glycemic control, by having a low glycemic index diet. To what extent this also works in people with normal glucose tolerance is more difficult to say, and that's still under investigation. Now, in these investigations we all are interested in, we need to have a good measurement. So this is really a task force which was interested in finding the best biomarker to investigate the sustained glycemic response of a diet. The OGTT, as I showed you in the earlier slides, is really the short-term response, so the response on a food within 2 hours. We will also be using a continuous glucose monitoring, most recently also used for research purposes, so not only for the control of diabetes patients. So you see here an example, the flash, but that also investigates acute effects. So you eat something and then you see a peak. or you don't eat something and then you see a lower glucose level. And that is not exactly what we are interested in looking at the glycemic response or the sustained glycemic response of a diet. HbA1c, we know from the clinical sites and the control of diabetes patients, it represents the glycemic control of the past 6 weeks. But it's not very sensitive in non-diabetics. In non-diabetics, it's all around the level of, let's say, well, below 36, for example, and there's not much variation. So you can only see something, it's sensitive in the higher ranges, so within diabetic patients. So we concluded that better markers are needed. So now I come to the aim of our study, to review the suggested markers of sustained glycemic exposures that could potentially be used to evaluate and compare the glycemic impact of diet in populations without diabetes. And we selected these markers: dicarbonyls, 1,5-anhydroglucitol, fructosamine, glycated albumin as a plasma protein, advanced glycated end products, and metabolomics. I already said we excluded the CGM, the continuous glucose monitoring, and we also excluded the HbA1c. For obvious reasons, it's already well known, and we know it's not that sensitive in NGT. We did a systematic search. The protocol is registered in Prospero, and we investigated human studies through July 2018. Well, and it's already time for an update, I would say, but at the moment, at that time, and still I keep track on it, not many more papers can be added for now. So in the end, we included 87 papers out of a total hits at that time of more than 5,000. So it was a huge work. And actually, we did a systematic search. The search string has been published, but we also noted that this type of work is very difficult sometimes to discern from title and abstract only. So actually, with hand searching, we added quite a lot of papers. Okay, I'll start off with one of the first markers. Like I said, glycated hemoglobin is not part of our investigation, but it's always good to have this in mind and to see it as some sort of comparison. And what happens with glycated hemoglobin, that the glucose, which is in the circulation, is being attached to the proteins in the erythrocytes, in this case the hemoglobin. This complex can be detected in the circulation. And because of the half-life of the erythrocytes, we can say that this HbA1c reflects the glycemic status of the past 6 weeks. But you can also have glycation of a molecule albumin, I'll come back to that later, of IgG or other serum proteins. And this will make this glycated serum proteins, or which is also called fructosamine. So I'm going to discuss this now. Glycated albumin, short GA. Actually, we thought, our conclusion, it's a promising alternative to HbA1c. Some background, and all my slides look like this. I'll start with a background, some information on the review, and then our conclusion on the pros and the cons of this as a biomarker for our purpose. Serum albumin is a negative acute phase protein. It's produced by the liver, and it's going down in times of stress. It's more sensitive to glycation than any other serum proteins because it's, well, a relatively long half-life, 21 days. Usually we express it as GI, as a percentage of total albumin. The level is about 11 to 15% in people with normal glucose tolerance when it's measured enzymatically. And in diabetes patients, it's 2 to 5 times higher. We found 7 papers to discuss, 6 experimental and 1 observational study. What we see as a pro, it's low cost, and it can be measured quite easily in a conventional enzymatic lab method, using a conventional enzymatic lab method. The half-life is 2 to 3 weeks, so this means that you can really use it for a little bit longer term than let's say the glucose, the acute situation with the CGM, but also for shorter exposures than the HbA1c. If you use the ratio of glycated albumin to albumin, that can help you also with getting away of some confounding factors that affect the albumin concentration. And in general, it's less confounded by chronic diseases and the presence of chronic diseases than fructosamine. But the cons are also there. Glycated albumin is reduced by higher fat mass, so that we need to take into account. And of course, higher fat mass is also a risk factor for diabetes. And it's also reduced by higher intakes of vitamin C. So it's not optimal. I need to go back to this again every time I move this one. Okay. So then it's logical to go to the next one, fructosamine. This is a term which includes all glycated serum proteins. The highest concentrations are glycated albumin and also glycated IgG. It has a similar half-life compared to glycated albumin, but at the moment there is no generally accepted standard reference range. Actually, we found more papers. It was more popular already, let's say 10, 15 years ago. 17 papers and 7 out of 70 trials reported a change in fructosamine. The result was they showed no modification by low GI diet. And we think that based on that, it probably requires large changes in GI or carbohydrate intake, which makes it a little bit less sensitive. The pros: standardized commercial kits are available, and it has reasonable specs regarding the QA, the inter and within inter-run and within run deviation. The cons are there are different assays, difficult sometimes to compare. Levels show variation during the day, and as you can imagine, it's influenced by the serum protein concentration itself. That's why, for example, in glycated albumin, we presented the ratio of GI to albumin concentration. For fructosamine, this is more difficult because it refers to the glycation of all serum proteins. A different type of measurement, which we thought were very positive about in the beginning, is 5,1,5 anhydroglucitol. It's also sometimes called glycomark. Actually, it's used as a marker of short-term glucose control in diabetes. And actually, it's measured. It's the hyperglycemic excursions leading to glucosuria produce a rapid increase in the loss of 1,5-anhydroglucitol in the urine, so it gets down. We found 10 papers on the 1,5-AG. 4 on changes after a sustained dietary intervention and 2 observational studies. But actually we found the levels are really unresponsive to variation in dietary glycemic exposure in non-diabetics. So this makes the use of it not very interesting. It is relatively low cost. Standardized, reliable assays are available. There are few major confoundings, and there is a rapid response, but maybe too rapid. So relative to the other markers, it has been limited used. So we need more. You only found 10 papers. There was very little published on this. And also a con is that there is for now limited evidence on the relationship with other markers and with disease risk for HbA1c, fructosamine, glycated albumin. We know to what extent it's related to the incidence of diabetes, for example. And that is, so that's why there's a reference range. And for this marker, this is yet unknown. A more complex slide now, and people from our expert group, Paul Thornelli, Nadia Rabbani, are experts in this and can explain this to you much better. But this is to show that we have other kinds of adducts happening or occurring in our body. And this is methylglyoxal, for example. This is taken up by the food, but a very small amount. It is also produced in our body, for example, here by the microflora and occurring in the tissues, and then, let's say, circulating in the blood as again an indicator of glycation. Nice slide. You can see here the exact quantification of the metabolism. The first we can call dicarbonyl stress. Well, with dicarbonyl, you have two carbons. They are attached to a protein, and they are actually degradation products of glycolytic intermediates and the glycated proteins I discussed earlier. For example, methylglyoxal, Mg, and 3-deoxyglucosone, 3-DG, are important molecules in this respect. Methylglyoxal is also able to lower or reduce insulin resistance. So actually it's a cause and effect of the hyperglycemia, which also makes it a little bit more difficult molecule to judge, so to speak. We found 10 useful papers, 1 RCT. The pros are really there: a standardized, reliable, and accurate assay available, a rapid response to glycemia. Like I said, it's a mechanistic driver of insulin resistance. At least there's much more evidence coming from it now. And also this glycemia and the vascular complications, very importantly. So that makes it very interesting. But at the moment, we need specialized equipment for the assay. Very quick sample processing, so that's not very practical because the very short metabolic half-life, 10 minutes, plays really an important role in this as a negative point. And there is really interferences, dietary sources, ketosis, etc. So from that point of view, at the moment, not ideal. Apologies, I need to go to this one. More complex products of these processes are the advanced glycated end products, or AGEs. Actually, they are more stable end-stage adducts formed in the glycation process. So, and this, you know that from cooking, the Maillard reaction, when you get browning, well, that's happening in your circulation as well. And this can be based on the fructosamine-related pathway, but also independent pathways. So that can be free adducts also from foods, but they can also be protein-bound. And they are based on the methylglyoxal we discussed earlier. MGH1 can be CML, fructose-lysine, glucosapan. Many of these can be found. Actually, we found quite many papers, 30, and we found that it was used in 8 experimental studies, or RCTs. A positive point: standardized, reliable assays are available, and they provide a cumulative measure of exposure because of their longer half-life. The free adducts in plasma and urine, they can really indicate to you what is the whole body flux of this protein glycation. So that gives you a lot of information. But there are also negative sides. It's interfered with by albumin, but also the food intake. AGEs can be present in food, for example, like in the brown foods like Coca-Cola and coffee, although there is discussion to what extent the levels are high in foods and to what extent this is bioavailable, but that's maybe for another task force. These plasma AGEs, and especially the free adducts, are very sensitive to decreased renal function. And obviously, renal function is also involved in the metabolic syndrome and pre-diabetes, so this may interfere with the measurements as well. And at the moment, there are only few immunoassays, and we need more standardized determination to really make comparisons across studies and methods. So again, not ideal. A final one I'd like to discuss is metabolomics in general. I think this is the new kid on the block already for some years. And in some of my own projects, like the food metabolome, foodball, we looked at it in more detail. What happens, we have all kinds of standardized procedures for the metabolite extraction from your sample, your biofluid. You had the chromatography to separate it, GC, for example, for volatile products. You have then the mass spectrometry to get an idea about the concentration and the identification of the molecule. But there are many challenges. There are many isomers, so this identification is really a big challenge. And at the moment, for most peaks, we don't have good identification yet. So it's really still at its infancy, but it can be very promising for the future. So at the moment, we use metabolomics a lot, also to detect new biomarkers. So it's you can use it as a global measurement of metabolites. And there are various techniques, like I said, we use the MS for the identification, but you can use also, for example, NMR, which is a non-destructive method. At the moment, we only have 7 papers in our hand, 6 on RCTs and 1 uncontrolled trial. Actually, some putative biomarkers were reported, but further work is needed in terms of validation. You see here markers of sucrose as opposed to glycemic intake, so sucrose intake, erythrotronic sucrose and fructose, they, as let's say, were found in an acute study. These molecules, dihydroxybenzoic acid and aminophenol sulfate, they can be potential markers, were found in a 5-week study, and this was found in a longer-term study. Now, the demonstration of dose response is very important. We need more work on that, and also more work is needed on the sensitivity and specificity. And finally, also, you can imagine that this measurement is quite burdensome. So what you want to get out of this, if you have this one single peak, develop a new quantitative measurement for exactly this molecule, which is more rapid and more cheap. And that it can also be measured in larger cohorts and larger intervention studies. So we need much more work on this one. Actually, all this I told you and much more information can be found in this paper, which was published in Advances in Nutrition, the review journal of the American Society of Nutrition last May, and you can find it here. There's also supplementary data available. Our conclusion is for the moment that glycated albumin is perhaps the most promising of the non-glucose molecular markers, but actually, at the moment, our enthusiasm is a little bit tempered by its potential confounding by fat mass. So it can also be increased in obese people. And this is something we need to investigate further. Ideally, we need studies, let's say, of 12 weeks. So that is, let's say, the amount of time, for example, we know from experience we are able to influence cholesterol metabolism. We'd like to see whether we can, with diets and products, carbohydrate products, we can affect the metabolism of glucose in 12 weeks time, where we can compare the glycated albumin and the HbA1c, which is for the moment the gold standard, but like I said, we know it's not that sensitive. So our overall conclusion that more rigorous testing is needed, and with every compound I gave you, let's say, the conclusion. So this closes my presentation for now. I give you a summary of what we did in the task force and a summary of what we have presented in the paper, and I'm happy to take any questions from your side. Thank you. Matt, can I give the floor back to you?
Yeah, you did. Thank you. I will take back the control of the presentation. Yeah. Thank you a lot for the very nice presentation and the very nice summary of the papers that was published. So now, basically, we're gonna. Oh, we now see you.
Yeah. Okay. That's not okay. I put it off. Sorry. Yeah.
Yeah, no, okay. It's fine. I wanted to just yeah. So if you have any questions, please feel free to ask through the questions section on the chat. We actually received already a couple of questions. Okay. So again, feel free to add more of those questions. Now we have 10 to 15 minutes, maybe a bit shorter. So I'll ask maybe the first question. You presented specific markers. So do you think a single marker could actually be of interest, or maybe a set of markers will be of more relevance and maybe more interesting for this kind of research?
Yes, I think this is a very important question. when we did a review and our discussions, you know, we wanted to draw conclusions for every marker or every method, I would say. And based on this, glycated albumin was our favorite, but not optimal. And then later, and this is also inspired by the work on the metabolomics, where we usually get a set of peaks which seem to pop up and are potentially interesting to serve as a biomarker. I think it could be very useful to investigate combinations of the things we have been discussed so far, like the dicarbonyl stress and the advanced glycation end product. They are related somehow to the glycated albumin and to the fructosamine. That could be a natural combination, but especially the metabolomics. I think that some of these leads can also be combined with a measurement of glycated albumin and give us a little bit more strength or sensitivity or specificity. But that is, an important topic to study. So that would be my advice for for our own work, not focusing on a single one like glycated albumin, but really try to enhance it with metabolomics or ages related factors to cover a broader picture of the impact on glycation. This also not only relates to the impact of the diet, but also relates to, let's say, the potential impact on health, because in fact that is what we are all doing this for, right? We are not interested in glycation per se. We are interested in glycation because we know it's relevant for cardiometabolic health. So from that point of view, inclusion of a set of markers is, I think, an important way to go.
Thank you. Another question is also reading at the paper. It seems like the main conclusion is that some more research is needed to make sure that some of those markers are actually relevant. So do you have any recommendation on how to basically conduct those kind of research in a way that will be more conclusive at the end?
Yeah, I think what I presented on the last slide, let's say a 12-week intervention with a proper control. So let's say a high glycemic load type of diet versus a low glycemic load diet, and then perhaps using a combination of markers or the markers we have so far, plus perhaps an on-targeted metabolomics analysis would be a very good methodological study trying to tease out, on a more systematic and standardized way, what would be good biomarkers for glycemic response. What we did now is looking at the literature, and what you see is that sometimes it's comparing apples with pears. So the papers per marker were very varied quite a lot. The interventions were shorter or longer with different types of diet, different types of products. So that is somehow confounds perhaps our conclusion. So to have it in a more standardized way and to have it tested, let's say in the same intervention, I think that would be an ideal first study. And next to, let's say, optimizing the measurements of some of the markers I have been discussing, like saying improving, also detection methods, identification methods in the metabolomics, and more easy assays for the dicarbonyl stress or the advanced glycation end products. So 2 types of research, I would say. Yeah.
Okay, thank you. Some additional questions from the audience. So in normalized diets, like when you normalize by proteins, is uric acid a good marker, especially for fructose intake?
Yes. Uric acid, I've been studying that quite a lot already in the past, and we start on a new study again. Uric acid is a difficult molecule. Well, let's say it can be a marker of fructose intake, but it's confounded by the fact that it is usually higher in people with overweight or obesity. And that is, in that case, you know, you can also see it as part of the metabolic syndrome somehow. So we see it clustering with insulin resistance, not due to diet. So fructose only plays a small or partly a role in determining levels of uric acid. So that is really some important thing to take into account. Of course, when a person is his own control in a diet where weight or you know, and fat mass stays stable, it could be useful. On the other hand, I think for fructose, the acute intake measurements, like saying measuring it just in urine, for example, is probably a little bit more direct and give you a better clue about the intake, for example.
And there's a follow-up question on this. What is the level of uric acid you consider high in people with normal BMI?
That's a good point. I cannot ask that now, but if I have an email address, I can come back to that question. Yeah.
Okay, great. We do have the email addresses, so we can.
Okay, that can be helpful. Yeah, I'm happy to provide that. Yeah.
Okay, great. Another question related to GA as a potential marker. So we basically claim in the paper that GA is a potential marker for this. Was those data confirmed with the cohort population?
It was confirmed in a cross-sectional study, I think from Japan. In Asia, GA has been used more often as a measurement than in European or American studies. So there are quite some studies in Asia using GA, but it was one cross-sectional study, so not yet a cohort. So we need more on that as well. Yes.
Okay, thank you. And a more maybe a general question. Could this biomarker be used on regular follow-up for dietary advice adherence for diabetic patients, or should they be used as companion diagnostics for fine-tuning the therapeutic strategy?
Yes, I think so. For real diabetics, I would say, you know, HbA1c is the clinical standard. It's also calculated automatically from your CGM device, for example. So from that point of view, I think we know much more on HbA1c, when it goes up, when it goes down, what the long-term consequences are for the diabetes complications. Although indeed on shorter term GA can help. So it depends a little bit if your patient, so to speak, is you know, has some problems with compliance, and the HbA1c you know, takes a while. A shorter intervention and having GA as a quick readout can be useful. I never thought of that, but just thinking aloud, I think this can be helpful for patients which are, you know, you want to convince them quite quickly that their dietary change can be helpful. So it can be quite motivating. Yeah, I agree. Good point.
Okay, thank you. And that will end the Q&A session here. I'm just going to go. Thank you, Professor Veskens, for your very nice presentation and your clear answers on the questions and your availability for this webinar. So thank you.
Yes, thank you very much for organizing it.
So I'm just going to end the webinar by just a few additional information on upcoming events for ILSI Europe. So we have the annual symposium this year is organized on October 6th, and it's a virtual event giving the sanitary circumstances here. And we will be providing a wide array of scientific topics, and we will start with a keynote presentation from DG Research Innovation on the Food 2030 strategy and policy framework. We'll have a very nice session on the role of proteins in sustainable diets. And we also will have a session on sweetness and basically trying to define how sweet is sweet, actually. And then we will share with you the latest update on the European project Fit for Food 2030 and practical tools and solutions for responsible research innovation for the food system transformation. And the final session of the day will be on the microbiome and the future of the microbiome research. Thank you again for your time and availability for this webinar. The webinar and the presentations will be available shortly on the website. And if you have the time, please complete the satisfaction survey that will start right after the end of the webinar. And thanks again for being here. And we hope to see you on other events within ILSI Europe. Thank you. Bye.